In this figure, we see blackbody data for 3 different temperatures: 3000 degrees Kelvin, 4000 degrees Kelvin, and 5000 degrees Kelvin. The x-axis of this diagram shows the wavelength of light emitted by the blackbody, and the y-axis shows the intensity of that light. Again, what we're seeing is the intensity of light for each wavelength depending on temperature. Now, what's interesting about this diagram is we've added the classical prediction for a black body of 5000 degrees Kelvin. That's supposed to be this blue line over here. That is what experimental data shows. And as you can see, these are way out of agreement. Let's compare the plots for 3000, 4000, and 5000 Kelvin. That is the red, green, and blue curves. As the temperature rises, what happens to these curves? Well, the wavelength at peak intensity shifts to shorter wavelengths as the temperature rises. As you can see, at 3000 Kelvin, the peak is in the infrared. And as we move up to 4000, we shift into the yellow range, and then finally to 5000, where we're in the white range. That is, if you look, the peak at 5000 is squarely in the middle of the visible spectrum. And let's look again at this classical theory line here on the right, this black line. It doesn't even remotely predict the data. This is for 5000 Kelvin, and the blue line is the experimental data for 5000 Kelvin. Clearly, what happens in classical theory is that the anticipated spectrum includes more and more electromagnetic radiation from shorter and shorter wavelengths. Classical theory, as depicted by the black line, indicates that the intensity of the emitted radiation from a black body should become infinite as the wavelength gets shorter. Another way of looking at this is that it predicts that black bodies should radiate most strongly in the ultraviolet and X-ray and gamma ray end of the spectrum. If this were true, of course, all black bodies would be emitting very, very dangerous high-energy radiation, and none of us could exist. As a consequence, this classical prediction was called the ultraviolet catastrophe. And of course, we're here, and data also shows that this does not happen.